We're going to solve the system using elimination. So you guys need to check the coefficient first. So let's look at the coefficient of x. It's 3 and 1. They're not same, or they're not the opposites. But if you look at the coefficient of y, it's 3 and negative 3. So it is opposite. So what you're going to do is you're going to add together to get rid of it, because plus 3 minus negative 3, this is a 0. So we can get rid of 0 when you add it. And 3x and 1x, if you add them together, it's going to be 4x, and it's equal to, what is 27 plus negative 11? Use a number line, then you can get 16. So x is equal to, 4x is equal to 16. So x is equal to 4. We're not done because we have to find the order pair. So how do you find y? You can get it by plugging in x to one of the equation. I'm going to choose the second one. So I'm going to plug 4 into here. So it's going to be 4 minus 3y is equal to negative 11. And this is 270 equation. So now let's get rid of, okay, let me use the black. Let's undo, edit by 4 by subtracting. So we'll be gone. Negative 3y is equal to negative 15 divided by negative 3 divided by negative 3. Y is equal to 5. So you plug in here. So the solution for this system of inequalities is 4 or 5, which means when you graph this, two equations and it will intersect at this point. A linear inequality in two variables such as y is greater than x minus 3 can be formed by replacing the equal sign. So it looks familiar if you have negative 3, if you have equal sign, right? Now we're going to just change it to inequality sign. That's it. And a solution of an inequality in two variables is an order pair also that makes the inequality true. It could be any order pair if that makes the inequality true. So it's not going to be just one. So for example, I'm going to just use the same example. So y is greater than x minus 3. So for example, any order pair which makes this inequality true, that's going to be the answer. So what if I put 5 for x? So I'm going to plug in 5, 2x. So it's going to be 5 minus 3 and y, right? I just plug in 5 to x. And if y is greater than 2, because 5 minus 3 is 2, any y is greater than 2 is going to be the solution. So 5, 3, 5, 4 can be the answer. 5, 10 is also the solution. So it's not just one solution like solving equations. The solving inequality has more than one solution. So you need to just find, oh, is it 5, 3 is going to be the solution for this? You can check by plug x and y. And if that inequality makes that inequality true, then you can say that's a solution. Let's look into more examples. Is the order pair solution of y is equal to, oh, it's the same inequality. So now let's see if 1 and 2 is going to be the solution. So I'm going to just write the inequality, x minus 3, and then substitute x and y. So x goes to, 1 goes to x, and 2 goes to y. So 2 and 1 minus 3, what do you think? 2 is greater than 1 minus 3, which is negative 2. Is 2 greater than negative 2? Yes, it's true. So this 1, 2 makes this inequality true, right? So this is a solution. Now, what about negative 3 and negative 7? I'm going to plug -3 and -7 into the inequality. So x goes to, so -3 goes to x because it's x and y, and -7 goes to y. So let me just rewrite it, and -3 and -3. And it should you need to see if this solution makes this inequality true. So -7, and what's -3 and -3? -6. Is -7 greater than -6? It's not. It should be on the right side of -6, but -7 is on the left side. So it's less than -7, less than -6. So it is false, which means this order pair doesn't make this inequality true. So it's false. So it's not a solution. Let's look at the question at the bottom. 3, 6. So now 3, 6 is a solution of this inequality. So x, 3 goes to x, 6 goes to y. So 3 goes to x, 6 goes to y. So now let's simplify. 6 is less than, so 3 over 1. So you can be simplified. 3 can simplify. So 2 over 1, which is 2 plus 4. Is 6 less than or equal to 6? Is equal to 6, so it is true. So is this one a solution? Yes, it is a solution of this inequality. One of the solutions, not just one. Okay, please copy it down. We're going to solve the inequality by graphing. So how to graph an inequality? It's very similar to graphing equations. And how to graph an inequality? Number one, use y-intercept and slope to graph. We already know that y-intercept is a starting point, and then you use a slope like rise over around how many you go up, how many you go like left or right. So you compare that ratio and put it on the graph. And if it has equal sign, if y is less than or equal to, or y is greater than or equal to, if you see the equal sign, the line should be solid, like this, like solid line. And if the line, if it doesn't have equal sign, if it's like less than or greater than, just less than or greater than, it's going to be a dashed line. Okay, second, dashed line. So it is going to be like dashed, which means the line is not included. Okay, line not included. Like the points on the line is included if the line is solid. So all the points on the line is included in the as a solution of inequality, but if a dashed line, it's not included. And number three, after you figure this out, after you decide solid or dashed, and number three is plug in one point from one side, just one side, to the inequality and see if the point makes the inequality true. So either this side or this side will make the inequality true. So you have to choose if it's going to be the left, it's going to be the right, like up or down. So if it's true, then you need to shade that side. If it's false, so when you plug in, let's say you plug in this point A to the inequality, but if it's true, then you shade it. If it's not, you're going to shade the other side. So if the other side, if it's false when you plug in A, then the answer, it means that the answer is going to be the other side. We're going to practice more. We're going to practice with some examples so that you can understand better.